Hello everyone. So we will wait for 2 more minutes for all the participants to um, join. Then we'll start the session. So my voice is audible to you people.
Yes, ma'am, it is audible.
Okay, fine. So today's experiment is already. I think it is already shared with everyone, right?
Yes, ma'am. Yes, ma'am.
It's a development and testing of a voltage regulator using Xenodiode. This is the experiment for today, tutorial session, right?
Yes, ma'am, it is.
Yes. So we'll discuss it in brief. I'll discuss the procedure of the experiment in brief, and then you can ask your doubts, whatever you're facing during the course of the experiment. So I hope everyone has joined, or else they can just have a look of the meeting. meeting video later. So we'll start. I'll share my screen. Just a minute. So the screen, just a second. So my screen is visible, hopefully. So I'll give you a basic brief of the experiment. So this experiment is regarding the use of Zener diode, and they have been used as a voltage regulator that we use in different applications in the course in the IDC course. Analog circuits course later on that you do. So this is a simple example of a voltage regulator using a Zener diode. We are using the Zener breakdown voltage of a Zener diode, and using that, manipulating that, we are able to generate constant voltage across the load resistance. That is, this is the load. So this is our, let's say we'll have pulsating voltage, but we will, even though this is a pulsating voltage, that it will change very rigorously. Then it is this, there is a source resistance connected to the source voltage to so that the Zener doesn't get damaged in case of uncontrolled current flowing out of it. So this is the Zener diode. Using the Zener diode, where it will be will work in the uh, reverse region, reverse region, and there will be the reverse breakdown voltage. Using that breakdown voltage, we will use it as a voltage regulator. That is the objective. Now, the materials and equipments, you will need two Zener diodes, the one kilo ohm resistance, one variable potentiometer, multimeter, and log ADLM kit 1000 kit that you have already been using for the last three experiments. Now here we have introduced the using of a simulation tool. This is an LT-SPICE software. This is a simulation tool software that this has been used so that we can, before going for a practical implementation of the circuit, we just implement the circuit in that software virtually, and see whether what are the expected outputs from our circuit. So in a way, we will have we'll get to know what is the expected results from our experiment, and then we can when we implement the circuit practically, we'll be able to understand, or will be in a much better position to uh, understand the circuit the working of the circuit, and also whether the output that we are getting from the real circuit is in the right direction or not. So it is very easy to troubleshoot any issues that will be facing while implementing the circuits in the real world. So this is a LTSPICE software. Maximum of the electronic circuits, analog circuits engineers, they use that in lab. Mainly we use this software. So it is very easy to use software. It is you can all even there is link given to you. I hope already everyone has downloaded it. So you just need to create a schematic as per the circuit diagram given shown in figure 1. This is a simple circuit. So what you have to do is give a voltage source Vs as specified here. So generate a voltage source consisting of a 4.3 volt DC source and a triangular wave with a peak voltage Vs2 of 0.5. volt amplitude. So what you can do is like direct way of using, you can use two sources, one, and keep them in series, or else you can just use a triangular wave which is varying from 4.8 to 4.3.8. That means if the DC reference voltage is 4.3 volt. Now if we add another triangular big wave on top of that DC voltage, so it will be what, the maximum peak voltage will be 4.3 plus 0.5, that is 4.8, and 4.3 minus 0.5, that is 3.8. Yes. So in a way you will be in this way also you can generate a triangular wave to emulate the variations in the input power supply. So this is why we have done, is to emulate there will be some in real life there will be some variations in the input power supply. So we wanted to emulate that or replicate it in our circuit and say that even though our signal is varying, we can get a constant voltage using this across the load using this circuit. Now what you will do is set the series resistance as 250 ohms, that is RS is 250 ohms, and select a Zener diode with a 3.6 voltage Zener breakdown, 3.6 volt Zener breakdown voltage. Now, voltage regulation can be of different type, but here we'll be using, we can use, we can either change the VS or you can change RS and see in what are the maximum limits that to which you will get a regulated voltage. So here in this experiment, we are varying RL and seeing that what are the maximum and the minimum limits to which if we keep our RL values, so that we get a voltage across RL, a regulated voltage across the load resistance. So that is the main aim of our experiment. So we will vary RL, keeping RS as 250 ohms constant. Now, we'll vary RL from 10 kilo ohms to 100 ohms and record the range of RL for which the regulator provides a regulated output voltage of 3.6 plus or minus 0.2 volts. So the regulated output voltage will be in the range of 3.6 to plus or minus 0.2 volts, and we have to find as we are varying varying the load resistance RL from 10 kilo ohm to 100 ohms. So we have to find the range at which maximum the voltage is regulated. We get a regulated voltage across RL. We have to, then you have to take the screenshots of the input and output voltage waveforms, repeat 6 and 7 after connecting two Zener diodes in series. Now in the step 8, what you'll do is, now here only one Zener diode is there. Now if you attach connect another Zener diode in series, now what will be the breakdown voltage, and what will be how the breakdown voltage will change, and how the range of RL at which the voltage we are getting across RL comes to be a regulated voltage, that will also change. Now, what you'll do after connecting two Zener diodes here, before it was 1, now it will be 2. So you have to repeat 6 and 7 steps again. Now, again, what you'll do is you will replace RS as 500 ohm. Before it was 250 ohms, now it will replace RS as 500 ohm. And do the same experiment, like do with single diode and a single Zener diode, and again according to step 8 with double diodes, 2 diodes. So accordingly you will change, you will measure the variation of or you will note down the range of RL at which we get a regulated output voltage. Now the last step in this part 1 is that form the circuit with one Zener diode. That means we'll have one Zener diode now, and RS will be 500 ohms and RL will be 1 kilo. So we'll keep RS, RL constant now, and there will be one Zener diode. But now what we'll do is that we'll vary VS too. Now we'll vary VS and check that determine the range of, and again we'll check that up till what range of VS2 uh, for which the output voltage is within the specified limits of 3.6 plus or minus 0.2 volts. So now we'll this VS2, no, we will vary that VS2 and check that to what limits we can uh, get a regulated voltage. So that is the first part of the experiment that you will do in LT-SPICE software. Hope this is a very easy software. You will be able to do it by yourself. There are ample amount of YouTube videos, and there are some source in this link as well, analog www resources, design and tools. You will be able to do that. You'll be able to do the. This is just basics of LT Spice. You'll be able to do that, hopefully. Now, what you'll do after you have get an idea. So, of all those things, you have to note down the values, and even though you will get it in LT Spice, try to calculate it theoretically as well. So that will give you a better picture of what is the circuit, how is the circuit is working, then what will be the expected theoretical value, rather than then you can again like compare it with the LT Spice simulation outputs. Now what you'll do, you'll go to next is this experimental study. You will repeat the same experiment using the components given to you. Now, so what you can do in part 2, the part 1 shall be experimentally verified. If the potentiometer available does not have the specified range, please test the RL for the available range. Now, VS can be generated with, using one of the channels, and the output can be observed using the other channel of the ADLM. Now, record all the relevant waveforms and include them in the report. Now, set up the voltage regulator circuit on a breadboard according to the schematic. Follow the same schematic diagram. Now, generate VS1 plus VS2. You can in the ADLM queue there are some options. You can just change from sine wave to triangular wave, and you can just change the initials like plus and minus, like pick voltages accordingly. This will be a triangular source with a DC of 4.3 volts using one of the channels of the ADLM board, and observe the output using the other channel. Now what you'll do, you will in across RL you can always connect a potentiometer that I think already mentioned in the so there will be a variable potentiometer. You can use that potentiometer as RL and vary that, and you can use that if the available potential range differs from the specified values, test RL within the available range. Now record all the relevant waveforms and observations, like that, the upper things. So mind you, you have to repeat the whole thing. So you have to connect two Zener diodes and change RS from 250 ohms to 500 ohms. Now again you can and repeat step 10 also, that saying that if you change the triangular like the VS, then what will be the range coming. So all those steps you have to do it in this part of the experiment as well, and show them in the in your experimental video. So that's all. Now if you have any questions or doubts, you can ask.
Ma'am,
Yes.
may
Yeah.
Ma'am, I have two doubts in the first part, ma'am.
Yeah.
So when I connect the RSS 500 ohms, should I observe the waveform when I connect one Zener diode and two Zener diodes in both
Yes.
the circuit? Ma'am?
Yes. Yes.
Okay, ma'am. And for the 10th question, so we have to vary the voltage source, no, ma'am. So
This
is it
one.
a trend?
This one. This. See.
Not that one, ma'am. The 10th one.
Yeah, I understood. So it
Yeah.
has been said that very VS2, right? That is VS2 is 0.5, right?
Ma'am?
You got my point. For example, here what you have done that you are connecting. One way of doing is you will connect one constant DC source and another voltage source, AC voltage source in series, right? What you are doing in
Yeah,
step
yes, ma'am.
3. Correct?
Yeah, we can do in that way also.
In that way also. Otherwise, you can directly just connect one source and just say that 4.8 to 3.8, the triangle sources vary, right? Now, what you can do is you can change that variation, maybe 4.4 to 4.2, like that, and check like that. Okay.
Yeah, okay,
Then
ma'am. So in this part, we can simply connect two voltage source, and the VS part we have to set
VS2
as like,
part, huh?
yeah,
VS2.
VS2 part in
We
for
have to
example
change.
4.3 volt or something like that.
4 point, maybe 4.3 is the reference DC. Now you keep at 5, and then the 4.3 minus 0.5, 0.7 will be 4.7, right?
Yeah, yeah, I
Like
got it.
that. Like that,
So
you change and
okay,
see
the
that.
one supplies
Hmm.
if I set one voltage as 4.3 and the other as and if I set the VS2 part as 5 and minus
Hmm.
5, so like that
Huh.
only.
Like that you
Yeah,
change
okay.
and see, specify the range of VS2 for which you will get the output voltage in the specified limits. Okay, that is 3.6 plus or minus 0.2 volts.
Yeah, okay, ma'am. Thank
Okay.
you.
Any more doubts, anyone?
Hello.
Yes. Yes.
Hello. Hello.
Yeah, you're audible.
There are three experiment, isn't it? Like one
Uh,
with only the Zener diode, one with both the Zener diode, and the third one is we have to find the range of input voltage for which the output is around 0.2 plus minus.
but then in step 9 also you have to change RS to 250 ohms to 500 ohms. Then again you have to connect one Zener diode to two Zener diode. This experiment again you have to do. Then is the last is the variation of the voltage
Okay. Okay. I
source.
got it now.
So first
Thank
is with one 250 ohms, one Zener diode, two Zener diode. Then RS will be 500 ohms now. Then one Zener diode, two Zener diode connected. Then the last is changing the voltage source. So you will do this experiment in LT Spice as well, and in experimental with your circuit components as well. So, but there should this all steps should be included in both the experiments. It's not that only you just do and just show it here in part 2, just simply you just show. No, it is all those things are included in part 2. Okay.
Hello.
Yeah,
And when is the deadline for this?
that
It's
I
not
don't know.
mentioned.
I don't know, you have to ask Victoria.
Okay.
I think this is the last analog experiment. Please confirm with Victoria. Okay.
Okay.
Okay, so any more doubts? Anyone have any more questions to ask? If anyone have any doubt, any questions? So in the experiment, I have one more additional information. In the LT Spice, you might find it difficult to get an Zener diode of breakdown voltage 3.6. I don't know whoever has tried to do the experiment, that they will know that I think this is for the minimum voltage breakdown Zener diode minimum breakdown voltage Zener diode available in LT Spice is 4.7. But here we are giving 4.3 the signal voltage, so it will not normally with this signal voltage, it 4.3, it will not show any voltage regulation for a Zener diode having a breakdown voltage of 4.7. So there should be there are some ways you can manually enter and make the Zener diode breakdown voltage to be 3.6. Just look into the previous just discussed among your peers, and I think there are some tutorials available in the YouTube. They will guide you to how to do that. Change the breakdown voltage from 4.7 to 3.6. So that you have to take care of. I think this is the additional information that you might face. That is a one problem that you might face while doing the experiment. Okay. If
Is the tutorial on the IITM channel or in general YouTube you are
I
referring?
think it is in the general YouTube also you will find, or I think during the last previous set of students when they have done during the, you can search in the this tutorial sessions that we have done. I think few of the students we have discussed in the tutorial sessions, so you can get an idea of how to do that. Okay, just have a look there.
Where are this video uploaded in YouTube?
We have a BS Electronics course channel, right, in the YouTube, right?
The main channel, or there is a separate lab channel also?
No,
Like
no,
other.
no. Oh, no, no. BS Electronics main channel. There will be some tutorials, playlist of tutorials. You can have a look there.
Thank you.
Okay. Any more questions, or who wanted to ask anything? If you don't have any questions, you can leave the meeting. We'll
Hello?
wait for, yeah. Yes.
Is there any specific reason why we are using 250 and 500 ohm resistance?
No, no, no. Not very. See, we are using 250 ohm. This is just a resistance to protect the Zener diode. Okay, so that not very high voltage, high current pass to the Zener diode and damage it. Okay, nothing like that. So, but why we are changing from 250 to 500 ohms? If you do the experiment, you'll get to know that the range actually changes. Like the range at which we get us that regulated voltage output changes when we increase the source resistance. So that also will affect. So this we wanted to see from the experiment. If we are changing from 250 to 500 ohms, but other than that, we are using the source resistance to protect the Zener diode. That is the aim. Okay. Before I will suggest everyone to, before going to do that experiment directly, just go through the theoretical explanation of the experiment, understand why is it used, what are the applications, and then you proceed with the experiment. That will help you to understand the experiment, have an idea of why you are, what is the need of this voltage regulation, why we are doing it, and why with Zener diode we are using it. So all those things you just have a look, understanding, and then you proceed with the experiment. That will give you a better understanding of the experiment as a whole. So if you don't have any doubts, you can leave the meeting. But I'll wait for 5 more minutes.
Thank you.
Yeah, thank you.